So yeah, thank you everyone. Apologies for the hiccups. As I was saying that from a Portworx perspective, we've been a leader in the cloud native storage and data management space. Enterprises have been using Portworx in production for over 3 years now, and we recently had a 2.0 announcement at the end of last year with KubeCon, which was both exciting from the sake of the releases from the team perspective, but also what customers have co-developed with us into this next era. So 2.0 really represents a culmination of years of production experience with our customer base, as well as the community as the systems evolved. And I wanted to highlight in some ways what's been going on. So I'll talk a little bit about Portworx, the case studies, the technology. I'll go into some workflows with Kubernetes just so you can understand how the two really work together in both a co-management fashion that enables this next form of transformation. And then I'll highlight with 2.0, both from the perspective of new releases, what it means feature-wise, as well as give a brief demo and walk through a couple of the top-level features, and then definitely save some time at the end for questions. So please stick around. If I talk about, what is everyone heading towards, and what are three possible examples of what customers are doing within their ecosystem or their data center, I wanted to pick a few that I thought were both timely and also relevant. This is actually one that Michael's team just published last week, and it's an excellent example of Roblox, which is for those who either play or have kids that play, they understand that it's the Minecraft, if you will, for more of the middle school age genre. And so it's an extremely popular immersive world system. And from that perspective, Portworx has been both a key partner as well as a provider to Roblox as they scale out on Amazon and Azure. And some of the key things that I thought were relevant or salient, it's a longer case study that every data center or every team can apply into which is, I thought two of them were extremely important. First is that there's a need to simplify the infrastructure. Kubernetes is extremely powerful, Nomad is extremely powerful, but all these systems very much want to give you a deterministic ability to schedule and scale. And what you really want is the ability to think about your infrastructure as being remade by containers. And that's what Portworx is doing, and it talks about this as we go throughout. And so there's the ability to simplify. The second one is really that simplification really means that the stateless applications and the stateful need to be as easy, in the sense that stateful should not be more difficult. It's not that everything has to be stateful or that the state is the only thing that's important. It's more that there has to be this symbiosis between what I can do from all my data-rich applications and seamlessly scale, because there is no such thing as a stateless application, if you will. So the moment I'm doing GitLab's, Mongo, or Cockroach, it really powers the rest of the services. And if I have a central bottleneck and I can only do stateless efficiently, then I really have limited my capability or the scope of this transformation. And then the last is really this point that, I think this tells the Portworx story very well, is the idea that there can be different classes of servers, and I'm just pointing out to Rob's quote here, there can be different classes of servers, but you really want your software infrastructure, or Portworx in this case, to allow you to reslice that based on your requirements. So we shouldn't be in this case where we design systems and we base our microservices on what the hardware platform is. Instead, there needs to be this intermediate layer, this platform, just like for Kubernetes for compute, Portworx provides that for storage and data management. So if I think about it, it's really the simplification, the idea of being able to do stateless and stateful as easily as each other, and the idea that I'm not tied down by my physical infrastructure. And especially as people think about growth, scale, and services, it could be a Roblox, it could be a simple microservices, but they all have a start and there's always a destination. And I think this is the idea that this explains in one succinct story what the customers are thinking about in the sense of building out these kinds of both GitLab, Jenkins, as well as these stateful applications. And I'll talk more about it at a general layer, but I wanted to start with Roblox as one customer example. And the other one is, a second one of three, is the idea of what Aria is able to do. And it's the idea that they're running, if you will, dozens of microservices on small clusters. And the perspective is that as teams form, and in their case, it's a little bit more of a acquisition strategy for them as well. But as centralized platform teams are formed, they give the company or the centralized company the ability to manage and provide centralized services that then every unique business unit is able, in this case, separate companies, every unique entity is able to then apply. And so if I think about the idea of what can you do with density, what can you do as you centralize your platform, it really becomes that you'll put these microservices, and these microservices will give you the capability to deliver based on unique requirements. And Kubernetes becomes the center of excellence, or the central point at which you can unify your control. And Portworx provides that same capability when it comes to persistence. And again, we're looking at applications like Cassandra, Solr, Memcache. And so there's no such thing as a stateless application. Just like Roblox, there needs to be simplicity. But here there's a unique story when it comes to the idea of maybe not such a homogeneous business user, but there's heterogeneous requirements, and containers provides the best form of agility to serve based on what those unique teams need. And then the third is really, I think, the next evolution that customers will get to, and Neo in some ways is leading this charge, is what happens when you want to do a full real-time system. So for those who don't know, Neo is a recent tech IPO in the US market, but they manufacture cars in Asia, and these cars will ship around the world. And in each case, there's this notion of autonomous vehicle, or driving, if you will. And from the autopilot perspective, there's this need to be able to quickly ingest data and quickly machine learn and provide not just personalized, but in some ways, very crucial results back into the user's experience or the vehicle is driving. And from a machine learning and a scientist point of view, there's this need for a heterogeneous stack that can do both what a Cassandra, Memcache, and the idea of a normal stateful service would do, but also machine learning. And so as we look at machine learning and what customers are doing, I think this is the bigger part of the story that all of the ecosystem and customers will be telling this year and into next, is that if we had this ability to do not just stateful services, what is the next thing it prepares us for? And it oftentimes for these customers becomes the ability to do machine learning and personalized results into their end customer's experience. And how does Portworx fit into that? And I wanted to give a high-level summary in some ways, and then talk about it in more detail. So acknowledge that this is really talking about this, the last point that Roblox was making is that there needs to be this new form of data storage and data management for the enterprise. And that's really because we are going to give the ability, our customers are needing the ability for agility, for personalization, for stateful services, for machine learning. And it starts with not being pinned by your infrastructure. So on the left-hand side, if I talk quickly about what Portworx does and then later on give more details, I would start with the idea that Portworx, what we provide is virtualized storage. And that really means that we leverage the existing infrastructure. So whether it's a solid state array, whether it's a flash appliance, even if it's the idea of local attached disks, Portworx is able to take those existing forms of storage and provide a multi-cluster, not just a multi-node, but a multi-cluster, and now a multi-cloud data management experience. And the second one is this EBS. The example with some of these customers is that running on Amazon. And Amazon provides excellent storage when it comes to virtual machines. But with Kubernetes, Nomad, and every scheduler, there's a need to provide persistence that follows the container or the application workload. And at that point, you do not want a host-based form or EBS form of storage. And that's what Portworx provides. And the third is just another example with SAN. So if I talk about it from a virtualized storage, people are very familiar with the idea that we fingerprint, we aggregate, we tier the storage. And that's a very well understood concept. But the middle column, what I wanted to highlight is really that we're now talking about a new user or a new customer base that is able to use stateful applications. And that really is talking about application administrators and DevOps. So if I think about what a physical array or what a host-based storage cannot provide me, it really becomes the idea of how do I provide a seamless experience in a controlled fashion for the sake of this middle audience, which is the DevOps and apps admin. And so from that perspective, it becomes how do we co-run, how do we do things like stateful set support, and it becomes a lot of the primitives that are required when these microservices have a different form, and you need to be deeply integrated both from a provisioning but also from a data lifecycle point of view. And that's something that we uniquely provide, and I'll go into more detail throughout this discussion. And the last is really that the grand unification of this becomes the self-service, that admins are able to, from an application perspective, back up their own application without interfering with another user. They're able to snapshot and restore. They're able to go through a catalog and say, what are all the things that I've in some ways archived, and how do I bring it back and not touch other applications, as well as how infrastructure teams and IT teams, who are the true enablers or users of Portworx and Kubernetes, how are they able to have a unified control and provide different classes or different qualities of service to each, and as well as protect that overall experience on a shared infrastructure. Because what we're getting away from is purpose-built hardware, purpose-built systems for one use case. Because as we get more agile, as we go more and more to these real-time systems, we realize that there's a need for shared infrastructure, there's a need for unified control, but there's also a need for self-service to each end application user, and they have to symbiotically cooperate, and we'll talk about that going throughout. And just a quick, if I had to give one slide that's an explanation, and this is one that obviously companies or teams that are already doing stateful will realize it's in some ways just a sampling point, but if I was to in some ways identify what I mean by stateful, it's really that stateful is anything form of NoSQL, relational database, content management like WordPress, and then analytics processing, this bottom row with Spark, Kafka, and Elasticsearch. These are just examples, and the key point here is that all of these have their own capability or their own requirements. And if I was to follow the approach that only worked for one of the applications, I would realize that I could not integrate it well with the form of what the next application will be. So it oftentimes becomes people know how to take one application example, take a one NoSQL and solve it for that, but they don't have a clean capability or ability to provide that required shared center of excellence or infrastructure that supports all these workloads. And again, these are just examples. Every day there's going to be more. I don't have time series, for example, on here. And these are all crucial to all the customer examples we were talking about. And it really becomes, in a polyglot world, how do you give the shared infrastructure that provides the best of breed application experience for each, as well as relying or providing it from the ability to centralize that control, centralize the resources, as well as centralize that center of excellence. And so that's what I'm really talking about, is the idea that we're moving towards this shared platform. And so if I talk more and less about the high level in the sense of what customers have done, but break it down and explain in some ways why it's necessary or what it might look like, let me talk about it in two examples, if you will. The first is that private cloud really means that you have control. You have control, if you want to talk about it from a technical level, at the IaaS layer up. But it's not just that, it's that you really can run this on AWS. You can really run this on-prem, and you can choose where it goes. You may not move it at microsecond boundaries, but over the phases of quarters and your planning cycle, you are not locked into a single provider. And so you have the ability to deliver a private cloud that is best of breed for your end customer or your end user. It provides all the platform services that a cloud would need. You're using Kubernetes for compute, and now you realize that stateful services, including with any scheduler, will want to be able to run on multiple availability zones, or if it's on-prem, in multiple racks. And there's no form of storage that is universally available without something like Portworx that provides you multi-AZ or multi-rack capability. And so if you want to be able to do high availability, to fail over from a rack to another rack, or from Amazon AZ1 to a second AZ, you realize that EBS is only per zone, not per region. And so Portworx, the first thing it does is it's able to unify that storage on the local disks and centralize that control and hyperconverge that into Kubernetes. And so what that really means is that not only will you have the ability to fail over, you'll have a complete integrated experience, and it provides the ability for isolated storage. So you're not providing EBS or a host-based storage per container. Instead, you're providing that virtualized storage or that Portworx volume for each application. And that allows you to move across racks, move across availability zones, but also more densely, if you will, pack applications where a single EBS volume can now have multiple applications, and Portworx will help you both in the sense of, as Michael pointed out, the cost savings, but also the idea of density and control and performance profiling for that application. So I can have multiple applications on a single EBS volume. If that EBS volume gets stuck or fails, I know it's available on another server in the AZ, and I also know it's available in another AZ if one of my AZ goes out. And we'll talk more about encryption, but I wanted to, in some ways, talk about it at the most anatomical level. And then let me just talk about it in a second use case, if you will, and say from a real-time perspective. So again, it's never a single application. It's never what can I do for one NoSQL, it becomes what can I do for the pipeline? And the pipeline really starts with the idea of, in a real-time or in some cases IoT example, I might have edge services or I might have edge devices, if you will. And those edge devices are collecting signals and they're always on. It's never that I want to provision a volume based on when a human's available from a pager, but I need to set policies and allow Kafka, if you will, to ingest as fast as it can. And if Kafka sees a broker outage, it's able to use Kubernetes or Nomad to reschedule Kafka. And at that point, Portworx has already provided the replicated data. And so I never suffer a brownout or I never drop my QPS from my end client because of this failover. I'm able to build more resilient real-time services. And so it starts with Kafka, it goes into processing. And I realize that in processing, you spend more time, oftentimes you spend more time preparing the data than actual execution. And this is another thing we're solving, is the idea, how do you ingest, how do you do it dynamically? How do you provide the ability to run through a pipeline, but you also have to be able to make sure that pipeline's constantly up and able to process through, because it really becomes, how do I provide this end-to-end service without suffering a bottleneck? And so we have to think about it from a full pipeline. And how do we shuffle the data for Spark? How do we shuffle the data for TensorFlow and provide both a scale up example as well as a scale out? And we can talk more and more about that as we peel back the layers. And the last is that oftentimes you have to store the results in a Cassandra or a NoSQL, and that provides you the ability to retrieve published stats. And so this is the grand unification of, obviously there is the idea of what do we do as database as a service, but it really becomes a full end-to-end pipeline. And here we're doing it with a real-time example. Now, if I talk about the technology, I just want to explain how we do it, what's the capabilities, and I've highlighted because I started with the use case, and then I'll end, if you will, with what's new in 2.0, as well as how those enable certain workflows within Kubernetes as an example. And so again, if we look at Portworx from a point of view, is that we're managing the storage infrastructure, providing you that data platform. And so we're unifying, we're aggregating the capacity. Here I've drawn it with SSDs. It could be a JBOD system plugged in. It could be Amazon EBS. It could be Azure managed disks. And the idea is you're able to detect, or we're able to automatically detect that local storage, aggregate the capacity. And that really enables that you can have the idea of running applications on any server. They can access storage across the entire cluster. And that gives them the ability to scale out. And if you want to talk about it, pets versus cattle, it is a cattle approach, but less from the academic point of view. It really means that you can maintain your cluster better. You can patch or in some ways remediate your system. And so one excellent example is what happens when you have Spectre or Meltdown, or what happens when you have the next critical vulnerability. And we'll talk more about that. And it really becomes, you want the capability to be able to upgrade each layer of your system independently and have an immutable approach. And we'll talk more and more about that, especially with PX Motion. But from that perspective, every server is able to participate in the cluster. Any application can run on any server and access it. And we can also make it both hyperconverged, as well as the idea of remotely accessing data, if you will. And the other one, the second point here is really that every application gets its own volume. That volume is going to be sitting or recarved from the underlying disk, if it's Amazon EBS, or it can be carved from a backend array. But it's available across the entire cluster, and that cluster is unified across disparate forms of infrastructure. And then we'll talk more about the scheduler here, and if you will, it becomes that it's very difficult as teams, and this is one of the lessons we realized in working with our customers, it's very difficult to scale and run microservices, not just with density, but with automation, without the idea of how does the scheduler cooperate with the notion of where the data exists. And so Portworx has implemented this as a CRD, or a Kubernetes custom resource definition, and everyone understands operators. You could think of it as an operator that enables you to, if you will, automatically place rules that say, if an application is running and the disk has the data local, and I can make it so that the application runs on the same server, make it automatically so. And that handles conditions of if the data is out of capacity, or I'm sorry, if the server's out of capacity, as well as if there's an outage. How do I make sure that I can fail over? How do I make sure that I'm scheduling a provision to the right characteristic? And as I expand out, how do I move or make my application follow the data, if you will? And the last, just to give a high-level example, is really the idea of what does this technology provide you, or what's the end-to-end flow? It becomes really that you want applications to be portable. In fact, portability is what gives you resiliency. And in order to create portability, you also want it to be secure. So one key thing that was early in customer feedback is how do we handle encryption? And so bring your own key encryption became an early example of how we integrate with a composable system. So customers could say, I have AWS KMS, I have HashiCorp Vault, Kubernetes secrets or Docker secrets. How do I plug that in so that the cluster itself is always providing me encryption at rest, encryption at flight, in flight, as well as my ability to control it from a backup and restore. So what we provide is the idea that we have two sets of keys, one for primary data for the volumes that are created, and then we actually can create and rotate the key for the sake of a backup, because oftentimes the backup administrator is a different span of control. And so it becomes the end-to-end flow is that you have to, in order to manage the data lifecycle, be able to provide the full end-to-end protection. That includes the idea of how it's securely accessed. So if I go more and more into workflows, I just wanted to highlight how this ties more and more, not just from what Portworx has built, but also how it ties into Kubernetes and provides you that automation and data protection. So if I think about it, one quick example is the idea of how do I recover data, or how do I handle it when I take a snapshot and I need to be able to use that snapshot and restore. And you could think of it as there's two classic forms. The first is on the left-hand side, we draw an application consistent snapshot, and it's the idea that a MySQL database here is writing and it has things stored in memory. But if I want to do a recovery, I need to get what's in memory and put it down to disk, or flush the disk, if you will. And on the right-hand side, if I don't do it, what happens if I don't have an application consistent? I fall back to the idea of a crash consistent, and there has to be a recovery check in MySQL on the right-hand side, because it has to understand that it wrote a stable write, but as it's recovering, what was in the memory, and it has to reconstruct. So there's always a risk there with a crash consistent snapshot. And the idea becomes, we're no longer thinking about it from MySQL, but we're thinking about it from multiple applications that form this pipeline. And they're doing so across a set of machines that you wanted to do it where Kubernetes is scheduling the machines or scheduling the applications on those machines. And from that perspective, we don't want to think about where that machine is, but we want to think about the intent we want to have. And so what we've done here is integrate the full experience. And again, this is through another CRD, our custom resource definition, the ability to control multiple applications, flush their memory, and for each application, they have a different requirement, and we'll talk more about that in a second, but it gives you a unified control to flush and in some ways ensure an application or ensure a total application consistent snapshot across a group of volumes and restore that in a way where it becomes more lights out. So if I think about what I want to do from a compliance perspective, what I want to do on a 90-day policy, and eventually what I want to do on a retention sovereignty perspective, it becomes how do I flush the application? How do I do so without requiring human intervention? How do I snapshot that and back it up to object storage and encrypt it? And in this case, I'm showing the end trip, which is restoring that. And so this really gives us the ability, if you understand, the ability to do what we've done in 2.0, which is move applications without interfering with the user experience as much as possible. And just to make the earlier point about the difference between the different environments of MySQL and Cassandra, it really becomes that you have to understand, or we have to, in a storage system, treat each uniquely. So from a MySQL, there's oftentimes the requirement to lock the tables. There's no such requirement in Cassandra. So each one takes a different approach, but all of these are generalizable for any database system, and they all implement based on each application tool's best of breed tooling. So it could be PG tool, it could be Node tool for Cassandra, and so on. And then one other point is namespaces that I want to highlight because it becomes the primitive that we use for how we do migration, is that if we think about it, namespaces are oftentimes a way for people to slice Kubernetes clusters based on different project teams or different span of control. And what you want is that a application in a blue namespace and a red namespace, to use two examples, aren't interfering in the sense of you wouldn't want the MySQL to access the volume of the blue namespace in this example. And so from that perspective, that has to also be true from the full life cycle, in the sense that as we back up and restore, you also don't want an inadvertent access to access someone else's namespace. So we have to understand that namespaces are a primitive that give us control. That control allows us to ensure the right thing happens from the application perspective. And we have to extend that fully from how we handle all future such capabilities, such as migration, which I'll talk about now. So if I talk about 2.0 and demo it in a minute, it's really that we have two critical functionality that I wanted to highlight. The first is PX Motion. What PX Motion is the ability to migrate from one cluster to another. And it's not doing so at the IaaS layer in the sense that you could be on any infrastructure. So this is not an Amazon specific approach or a on-prem only approach. You can use this on-prem, you can use this in public cloud, and you can use this on-prem to public cloud. And what it really is talking about is I'm not going to just move my data. In some ways, that's probably the classic approach 10, 15 years ago, is you just move the data. But now what we want to be able to do, because we're talking about microservices, we're talking about automation, we want to be able to move the applications as well as the data. And from that perspective, it becomes the entire flow of how we move the whole entire cluster from the left-hand side to the right-hand side. So if we will, just a second, I'm going to tee up a demo just to show you. So apologies for screen swapping in a second. But I wanted to show this from a PX motion perspective. And this is a demonstration of PX motion. And let me make sure I'm full screen, if you will. I think this is probably the maximum screen. And let me talk through it, if you will. So on the first side, we have the source cluster. And what we're seeing is it had 11 volumes and it's running. And on the second cluster, the destination cluster, it only has 1 volume. So the idea is we realize that the source cluster is more heavily loaded than the lightly loaded cluster. And maybe we're preparing for a incoming amount of data or incoming amount of demand. So what we'll do first is to show there's nothing up the sleeve is we'll show on the source cluster a bunch of PVCs, a bunch of applications, and that was Kubernetes Git pods. And if we look through it, we can just see that in Lighthouse, and I'll walk through this UI in a second, you can see the full entire set of applications, and we can even drill in and start to analyze the volumes, if you will. So that's just an example. And then if we look at Grafana, we're seeing that the source cluster has a high amount of load, 70 to 74%. And the idea is we know that at some point we need to migrate or create capacity. And so we look at the destination cluster, it's only using about 1 to 2% of its capacity or its CPU headroom. And so the next thing we'll do is, this is an example of the CRD here. It's called storage orchestration or STORC. And we will have the idea of cluster pairing. Pairing is this trust relationship between the source and destination cluster. You can actually pair multiple clusters. And the key point becomes here is this is how we use the extension to create the ability of 2 clusters trusting each other, and afterwards allow teams to migrate just their namespace. So obviously migrating just their namespace ensures, to the earlier example, that the red and the blue, only the red is migrating the red, only the blue is migrating the blue. And an example could be, I know I'm planning for the next version and I need to create capacity, or I need to back it up, if you will. And so I want to make all controls available at the namespace. So if I look now at the destination, I'm looking at the cluster pair, and it's pairing through, and it's going through multiple phases of ready, or to the point where it's ready. And then I can go through and start to look at migration. And migration itself is listing through my structure or our structure of how we want to be able to enable this migration. It identifies which cluster trust relationship it's using here as cluster pair. Include resources is important is because you can move just the data, and in that case, it would just move the Portworx volumes. But if you include resources and set it to true, you're also moving the PVCs, and not just the PVs, you're moving the PVCs, the config maps, and everything in those namespace. So that includes the pod specs, the replication controllers, the deployments. And what that really means is you have the ability for all of the application to move as well. And from that perspective, we're remapping everything so that obviously things get tied down to infrastructure, but we understand the full relationship, and we're able to remigrate or migrate the full entire stack. And this next value here, start application true, really means that, do I want to launch it and make it so that it automatically turns on? True means that it will start the moment it's migrated and it's complete. False would mean that the replication controllers, as an example, will be set to 0 instances. So they're ready, the controllers are up, they just are asking for 0 instances to be or 0 replicas to be the desired state. So as we go through, we're looking through, and this is actually executing the migration on that trust relationship between that 74% cluster and that 1.6%. It's migrating and it's going through, and its phases it's going through is the first stage is it's migrating the volume. So the count is going from 1 through 11. And now you can see at the UI, it's actually a little bit ahead. The UI is caught up, is that it's migrated already 9 volumes to the destination cluster where I originally only had a single volume. And that's the first phase, is we're starting to move the data. And that is both a incremental snapshot as well as something that we can do catch-ups based on. And incremental really means that that snapshot moves only the differences. Obviously, the first time it's the full stack. The second time it's the difference between the prior migration. And the next stage is the application. It's really saying, I'm moving all those Kubernetes-based resources. So that really starts to become the Kubernetes objects, the PVCs, the config maps, the replication controllers with their pod specs that we just talked about. And in this case, what we were able to then see is go through and see the full complete. And at this point, we're just going to look through, and this is just switching the context to talk to the destination cluster. So now I'm on the destination cluster. We do a kubectl get the pods, and we see that all the pods have now moved. And then if we drill through, we're able to go through and look at the destination cluster, see that all the volumes that we asked for in that namespace have indeed moved, and we'll actually want to check it one more time. And if we look at it from that perspective, we can actually see that in some ways the load is touched up, if you will. So that's an example of making this so that it's a completely, in some ways, an end-to-end system that you can just enable your infrastructure to have different controls for each application owner that are fully within the definition of the IT administrator. They're able to migrate not just the data, but the applications as well. And if we keep going and talk about some of the use cases that our customers have been testing this with or piloting this with, it's the idea of creating capacity. So I have no, and that's what we illustrated in the demo a second ago. I have idle capacity on the right-hand side, and I'm migrating the left-hand cluster. The second one, and this is one that we think is going to be important, is we can also migrate with next version of Kubernetes or the next version of Portworx. And that makes the ability for us to test and test with data. And it's really becoming the ability that I can say, I have a new version. There's a critical vulnerability. I want to make sure I understand end-to-end that my application stack works with my data. I will test it, and I can decide which cluster to keep. And so it's really becoming more immutable in how we control and think about our infrastructure. And then from that perspective, if we talk more about the concepts, this is the illustration, and I will in some ways go through this quickly because it's available online, is that we pair clusters. You can trust multiple clusters. These are the common use cases that we've been working with our customers on. And then PX Central is something I'll walk through as well, as the idea that we have a centralized GUI. That GUI makes sure that the full control is managed by Portworx, and it provides a full integrated Prometheus Grafana an alert management system. And so it becomes that this PX Central on the left-hand side is able to manage many PX enterprise clusters. And it centralizes, if you will, that experience, and also is able to drill into all the specific applications as well. So this is a live cluster that we have in our co-location facility, and we're looking at 3 clusters through a centralized GUI. And if I wanted to click through, this Grafana link actually launches, and it clicks in and says, it looks at that specific cluster, and it talks about the actual usage. And we're able to look at the heat maps of memory, compute, and actually drill into each individual layer. And if this was to keep going, what we can see is we can create alerts and rules, and we can start to say, this is my policy for how I know my application is healthy. This is how my policy for how I can think about my cluster. And in some ways, create that full automation, single pane of glass, if you will. Because here I'm looking at one cluster, but obviously I unify this across, and I can look at multiple systems in a live, real-time fashion. So I realize that we're running to the top of the hour, so let me just highlight a couple of things that you can do with PX Central, and then definitely set some time aside for questions. PX Central, we have the multi-cluster GUI capability, centralizes the configuration for snapshot. That's something that Roblox or Rob talks about in his longer case study with us, is the ability to create in Lighthouse these rules for how snapshots are configured. And then it builds in all the metadata services. So from a customer's perspective, all you have is PX Enterprise, the cluster, and then you have this central that configures and manages and provides in the metadata services that are required. And the last is this proactive monitoring. And obviously this is what PX Central has today, and you can imagine that we're improving it all the time based on customer feedback. And a couple other things is you can see all of these in very crisp detail on our docs site. So please take a look at docs.portworx.com, and you can see migration and management there. A couple other, or a few other additional features that I wanted to highlight in 2.0 is really the idea that we've added things like restartable snapshots. And the idea here is both from a migration or from a backup perspective, if the connection gets interrupted, we can resume from where we paused. The next one is really the idea of shared volumes. The key concept here is application teams oftentimes require exclusive volumes, and that's what we have as block volumes. But they also, in a different pattern, require multiple reader, multiple writer, if you will. And that multi-writer case is what we use with that's what shared volumes provides. And then journaling and performance is really the idea that we're constantly improving the capability to take applications and tune and create, in this case, using journaling as the technique to create better IO characteristics or lower latency profiles and control that through storage classes, if you will. So one last slide is just to say thank you very much. I want to make sure we save some time for questions and answers. I really enjoyed sharing this with you. Please reach out to us to request a demo, read more about us in our 2.0 content in our customer case studies, and reach out to us and let us know how we can work with you. Thank you. Michael, appreciate the time. Do we have questions?
Yes, so just a reminder to anybody who has any questions for Eric, please go ahead and type them in now. One question to start with, Eric, is I think a lot of the use cases that you provided with Roblox and Neo are some very mature customers. Can you talk a little bit about some of the patterns you see with customers who are getting started running stateful services on Kubernetes? What are some popular applications to get started with?
Yeah, that's a good point. So I will say that some of these customers are mature. I would say some of them are newer as well, but they do have a level of background or expertise that your point is exactly fair, is that they're able to also understand the end state. If it's the idea of getting started, I would suggest a middle, and then I'll suggest an even earlier beginning. The middle phase is really oftentimes, what do we do with a MySQL or a WordPress, if you will, or a Postgres database, and how do we handle those kinds of relational database scenarios? And then MongoDB also has a master-slave replication use case. So it becomes, how do we ensure that multiple or one or two databases are able to be managed, protected? And that's in some ways the middle case. An earlier getting started is oftentimes customers will look at Jenkins, and this is also included in some of the customer examples we showed at the beginning of GitLabs, or Jenkins or GitLabs are these build systems. How do we handle the pipeline? Because obviously Jenkins always has a constant shuffle of data going through, and you can always regenerate it from your CI system. But you also, if you're serving your customers or your clients, you want to be able to do so efficiently and quickly. So you're oftentimes using checkpointing or data to be able to, in some ways, provide that higher level of service. And so it becomes Jenkins is a very good way to get started because it's regenerative. It has a full end-to-end pipeline, and it ties back to the end customer, and it's very real time in terms of what you can do with a Jenkins system. So just to summarize, middle is oftentimes relational or NoSQL databases. The very beginning is oftentimes a CI system. And as you pointed out, the very end could be things of full stacks, infrastructure level thinking, as well as the idea of eventually getting to machine learning.
Okay, great. So another question is more about Kubernetes itself. Can you, the multi-cloud is obviously a big trend right now. And if you're going to do multi-cloud with Kubernetes, you'll have different Kubernetes clusters running in different environments, on-prem, cloud, et cetera. Can you talk a little bit about what you're seeing in terms of the ability to do multi-cloud Kubernetes with the Kubernetes managed services that might be provided at the major cloud providers? Meaning, if I want to do multi-cloud between Azure and Amazon, how does the managed Kubernetes side of things work? Is that something that is viable? Is that something that, I should run my own Kubernetes cluster in each of those environments if I want to do multi-cloud? And what is your perspective on that?
Yeah, thank you for that question. I've worked on some of these systems in my past life. I'll say there's probably one quick distinction between a managed and a hosted service, in the sense of a managed distro oftentimes starts to talk about we're changing the underlying flavor of Kubernetes. And so I'm reading a little into the question, and what I would say is that there's the idea of what is a curated distro that might have some modifications, and probably in some cases for good reason, but what does that look like? And that really in some ways helps, but may hurt. The other part of your question, which I like, is the idea of how do I provide a multi-cloud experience? So if I look at a hosted that is upstream and vanilla, oftentimes what we see is that if you're sticking true to the idea of what vanilla provides you, you can create the capability of a multi-cloud experience. And that's oftentimes what people are doing, is they're saying, I'll use the EKS, GKE. But at the same time, what it's providing them is the masters are managed, and Portworx obviously works in a GKE, EKS environment. And so you can create the idea of an EKS cluster in the cloud, getting and working with an on-prem cluster or a GKE cluster. And that's a couple of the demos that we have today on our blog is migrating to GKE and vice versa, and migrating to Amazon EKS, if you will. And then just to go back to it, a curated distro starts to change that. So at that point, if I was to look at a very curated PaaS style system that uses Kubernetes as the underlying construct, I might then be tied only to migrate between the two. We do migrate and support PaaS systems, and this is great that customers do this, but in the example here is that we do support OpenShift, and we have OpenShift customers in the federal and the financial spaces who use all of these features, test PX Motion and use PX Motion, if you will. And at that point, you're using PX Motion between two OpenShift as opposed to OpenShift to hosted. So that's reading a little more into the question. If others have questions about that, happy to talk more offline as well.
Okay, great. And we have a comment to the answer. Just I think we've got someone, either a fan of IBM IKS service, or maybe someone who works there, who's saying in the case of IKS, it's a completely vanilla Kubernetes service, not a modified version. To your point about the distinction.
That's right. And IKS, that was in some ways something I should have identified early on. Is IKS has been a critical partner and worked with us closely. They actually have some of the. I know I was looking at the docs just a second ago. They have some of the best docs I've seen about both Kubernetes and how to work with Portworx in Kubernetes environments. So IKS is also a great demo of how do you take upstream vanilla Kubernetes, and then Portworx provides this overlay, if you will, that works across their environments and into multiple clouds.
Okay, great. So a few more questions. One is maybe going from kind of broader multi-cloud to multi-region. So one person's asking is, can Portworx work in a multi-region setup? And then second question as part of that would be, does multi-region example, can we have one cluster, say, in Dallas and one in Washington, D.C.? How would that work?
Yeah, so I think multi-region, we have to get to the question of latencies. So if I look at the build out, there's a question of synchronous, asynchronous, and then latencies, if you will. And so just to read into it, what you could say is, would I ever run a cluster from two regions with high latency and make it synchronous, where you could make Portworx span it, but would you want to? And the suggestion here is you wouldn't necessarily, but what you'd want to take advantage of is cluster pairs, PX Motion, creating a schedule that migrates one cluster to the other so that the applications aren't bound by the latency. Instead, you're able to provide that automation management at the infrastructure level and not make the application feel the latency between the regions. And I realize that's just one example of your reading into the question. So let me take it the other way. Yes, you can obviously do multi-region. It's actually extremely important, especially for enterprises. What they realize is that they used to use Oracle and log shipping. Maybe they had something like a NetApp SnapMirror, but none of those work in this ecosystem. None of those provide you Kubernetes-based migration, ability to remap the PVCs, ability to augment the RBAC to have the full control. And so the answer really is prior art here has the right ideas, but does not work in these systems. And that's what we are providing. And so happy to talk more. And the answer is you should do this. And there's two different patterns. One is to make a single cluster span. The other one is to do it based on a migration like a PX Motion. And you can realize that obviously we're investing more and more in this area.
Okay, great. So one other question about Lighthouse. You showed a demo with Prometheus and Grafana. So the question is that out of the box? Meaning when you install Lighthouse, do you automatically get access to Prometheus and Grafana?
That's right. We provide both. So here's a couple things. One is just, sorry to get philosophical, but I would say that we have to provide best of breed tools out of the box. And that's what Lighthouse, PX Central provides you, and Prometheus and Grafana. Obviously, customers also have different systems because this is a composable infrastructure world. So you can imagine that the tooling becomes composable. So we also support Datadog as one example, and others are down the road. For example, we're pretty excited about what Sysdig is doing. So the point is, you can replace Prometheus Grafana with a Datadog or a Sysdig. And so you really need to be able to manage or control within your viewpoint. Now, back to the core question, can you take it, is it out of the box? It's out of the box. The Grafana, if you will, the templates are built in. And so you can download our templates, they're free, and they give you the ability to already have a configured visibility. And you can use it in your existing Grafana, or you could use it with Portworx, where we're setting up and managing Grafana for you. Both are possible. So you can use it, the templates in your environment, in your control system, using our setup in your environment, as well as using something like a Datadog or a Sysdig.
Okay, great. So lots of good questions this morning. So another one is kind of has a security angle to it. So the question is, are there considerations when working with a Kubernetes security solution like Twistlock, particular security or compliance items to hone in on?
Yeah, I think there are customers that have used both Twistlock and Aqua Security with us, and I think those are all exciting points. I think some of the things that we've invested or started looking at is how do we create profiles that are built into their systems as well. So just to take the core question, can you work with both? The answer is obviously yes. And you can imagine that what we want to see get better is all the tooling has, just like the Grafana templates, but it has default in Aqua's example, profiles that help it so that you can monitor with an understanding of what the access patterns are here. So yes, you can work with it, and this is an area that we're actually pretty excited about as well.
Okay, great. So it looks like we've got one last question. And it is, if there's a storage failure, what happens to data in memory?
If there's a storage failure, what happens to I mean, so the key point here is that the way to control data in memory is through application consistent snapshots. But obviously, if there's a, let's say, server failure, just to generalize the question, if I hadn't taken a snapshot, what do I do, right? So it becomes my snapshots, including application consistent snapshots where I flush the memory, become the way that I have backup and restore points. If you have a failure that is after that boundary, like let's say you didn't back up for a day and suddenly you have a failure, obviously the next machine has to have it. So the next machine from our perspective is through the idea of what Portworx provides through the replication at its layer, as well as tuning with the applications. Some systems will do great, and some systems, for example, Kafka, the broker, will still have things in memory. It's rebalancing. The data is persistent on disk. If you have a broker, you only suffer whatever is in the broker slight memory, but the disk already has it, so it works great. And if you have a single point of an application, obviously, then you have to realize that that application would have had to add a system that fails over for it. And so you have to design for that, and you can be exposed if you didn't design for it. A great example there is we do support things of how you work with master slaves, because operators and CRVs are making that better, and a leader election has to support, just like with Kafka, with a Percona or Percona Mongo system. And so those are all areas that I think are even getting better so that it doesn't happen. So you have to design for it. There are built-in techniques that make it possible, and that is actually something that has to be there in the sense that you should demand that your vendor, your Portworx, or if you choose someone else, which you shouldn't, but you have to demand that they understand how to do that with you.
Okay, very good. Thank you very much, Eric. Very informative, and thank you everyone for attending. If you have any follow-up questions, please contact us. Eric shared the request information link with you. If you forget to write it down, just go to portworx.com and then click the big button at the top that says request a demo. That will send a question directly to our solution architect team, and we'll get back to you, within the day to answer any of those questions. Thank you very much for joining us, and I hope you have a great rest of the year. Thank you.
Thank you. Thanks, everyone.